homework 3-7. We're getting close to the end of this unit. And we're still talking about probability, and will be for a while. In this problem, we have a 12-sided die labeled 1 through 12. Each number is equally likely to be rolled. What's the probability of getting a number greater than 10? Okay, so remember the sample space here is going to be 1, 2, all the way up to 12. So there's 12 options. We want to get greater than 10. So those options of greater than 10 would be just 11 or 12. We would not include 10 since it says it's got to be greater than 10. All right, so there's only 2 out of the 12. So we'd say there's 2 out of the 12 choices. I'm going to leave my probability like that. I could reduce it. I think they'll give you credit for either one of those. All right, and this next one, we're dealing with a deck of cards. Okay, so hopefully everybody knows what a deck of cards is, but if not, they've listed them all here for you. All 52 cards that are in a deck, no jokers here. You have 13 hearts, 13 diamonds, 13 spades, 13 clubs, and then here are the different types. There are 4 aces, there are 4 twos, there are 4 threes, etc. All right, so we, in this problem, suppose that one card is drawn at random from these 52. What is the probability that the card is a face card? Okay, so here we are. We have the face cards over here. It looks like there are 12 of them. So you'd have a 12 out of 52 chance of getting a face card. 52 total cards, 12 of them are face cards. 12 out of 52 chance. You can leave it like that, or you could reduce it. What is the probability that a card drawn is a spade? All right, well, we got to figure out, well, how many spades are there? Here are the spades. Looks like there's 13 of them. So you'd have there's 13 out of the 52 cards. That's my probability of getting a spade. I could reduce it. If I did, I'd drop it down to 1/4. All right, and then finally, our last question is, what is the probability that the card drawn is a face card or a spade? All right, so you got to be careful here. Face card or a spade. So let's just review. There's 12 ways of getting a face card. There are 13 ways of getting a spade. We want to know what's the probability that the card drawn is a face card or a spade. All right, so my face cards, let's just think about it here. Here are the face cards. Here are the spades. All right, so that is, I have 12 here, 12 chances there. I have 13 chances here. However, if I'm paying attention, these 3 get counted twice. They get counted in both sections, those spades that are face cards. So I don't want to count those twice, so I'm going to subtract them out of here at least one time, so they just counted the one time. So when I do all that, I've got 25, that's 22 different possibilities out of the 52 cards. All right, so basically what I did was I found the probability of getting a spade, added it to the probability of getting a face card, and then I subtracted the overlap. The spades that were face cards. Okay, this is where we start getting to a little bit more complicated stuff here. So this overlap were the spades that were face cards. Or face cards and spades. Okay. All right, got some practice to do on those. Let's see what's our next problem. All right, here we go. We have a deck of 8 cards numbered 1 through 8. Some are gray, some are white. You can see that over there. The cards numbered 1, 2, 3, 4, 6, 7, and 8 are gray. The only one that's white is 5. You draw a card at random. Let X be the event that the drawn card is gray. And let probability of X, or P of X, be the probability of getting a gray card, basically. So we're just getting into writing some expression here. Let not X be the event that the card drawn is not gray. So we've got, if we look at this, there are the probability of getting a gray card. If X is standing for getting a gray card, the probability of getting a gray card is 7 out of 8 chances. The probability of not getting a gray card, there's only 1 out of 8 chances for that happening. Now, this not X, you're going to see that written like that. This is called the complement. These are complements of each other. Complements always, if you were to add these up, they should always add up to 1. Okay? Total probability would equal 1, so the complements of each other add up to 1. In this part right here, that's just, you're just checking boxes, and then your answers are going to go here. Let's look at a little bit more difficult problem. It says a basket is filled with 7 white eggs, 14 brown eggs. That means there are 21 eggs in this basket. Half of the brown eggs are cracked. That means I have 7 cracked brown eggs. If an egg is randomly selected from the basket out of these 21, what is the probability it's a cracked brown egg? Okay, since I have 7 cracked brown eggs, I got out of 21 eggs, I'd say I have a 7 out of 21 chance. Reduce that, I got a 1 out of 3 chance of getting a brown cracked egg. All right, got some of those to play with. Have fun. Let me know if I can help.